Hello everyone, it's Dino. I'm going to be showing you how to do inequalities. So basically inequalities is basically, let's say we have a number line. Let's make a quick number line. So in the middle we'll put 0, 1, 2, minus 1, minus 2, minus 3. This could go on forever. We're just going to make a draft one here. So an inequality is a section of this number line. So let's say minus 2. So let's just color it in to, let's say, 1. So this inequality would be minus 2. So basically this value we have here, like this section, we'll just call it x. So x is between minus 2 or equal to minus 2 and between 1. So this would be our inequality for this. But let's say, let's draw another. So let's say we make another number, but instead of coloring the dot in, we are just going to leave it a gap and put, let's say, here. So then our inequality would be minus 3 x and 2. So it's less than 2, but it's greater than minus 3, as we can see. But it cannot be minus 3 or 2 since this is not colored in. But if we were to color this in, it would include minus 3 and 2. So that's how you draw basically the number line. So basically this question. So for question number 1, write down the values of two values of x that satisfy the inequality. X is less than minus 2. So if we were to represent this on the number line, let's increase this a little bit. Let's put minus 4 and minus 5 here. So it says that it could be any number less than minus 2. So we know that we cannot use minus 2 since this is a normal less than sign. But if it were a less than or equal to sign, we can use minus 2. So as we can see, there's a lot of numbers we can use that is less than minus 2. We'll just go for question 1. We can just say minus 3, minus 4. And that would be our answer. Let's move on to question number 2. Write down the integer values of x that satisfy each of these inequalities. So for here, it didn't give us a number, so we have to write down all the integer values. So let's write 2a here, minus 4, x, 0. As we can see, this is a less than or equal, or greater than or equal to sign, while this is just a normal one. So we can just put this in the number line. Let's draw another number line. It's not necessary to draw a number line. I'm just going to show it since it's easier. So let's write minus 4, minus 3, minus 2, minus 1, and 0. So we can see that this is a greater and equal sign. So we can just color it in. And then this is just a normal sign. So we can just leave it as a blank space. So our values, our integer values that will satisfy x is these numbers. So we can just write down answer, or x equal to minus 4, minus 3, minus 2, and minus 1. And that would be our answer. This goes for all the questions. You can quickly do them as well. So like, let's just see number B. We can see that this is a normal sign where this is a greater or less than or equal to sign. So we can just write the quick values. So 0, 1, 2, 3, 4, 5. As we can see, it's equal, and this, so we cannot include, it's going to be 2, 3, 4, 5. I did a little mistake. Same with number C. So number C, we can see that it doesn't include 1, so it's going to be 2, 3, 4. Same thing with number D, we can see that it's minus 5 doesn't get included, but minus 1 does. So it's going to be minus 4, minus 3, minus 2, and minus 1. Let's move on to the next questions. So we can see that the numbers here basically it told us to represent our solution on a number line. We already did this, so we'll just continue doing it again. So question number 3. Let's do question number 5. These are a bit different, as you can see. So let's try to solve them first. So let's do question 3 first. So question 3, it's going to be x minus 3, 4. So to simplify this, we can just remove or like add plus 3 here, and as well as add plus 3 here. So this would remove this minus 3, leaving x only here, but it increases this number. So it's going to be 5, 6, 7. So we've got our simplified inequality. We're just going to put it on the number line. So let's draw. We don't have to draw or write all the numbers. We can just write 7 here, and since it's in less than or equal sign, we can just color it in. We can do these for the rest of the questions. Let's do number 7. So number 7 would be, number 7, question 7, 3x minus 4, 8. So we can add 4 here as well as here, and then basically we could 3x, remove the 4 here, but increase 12, and we can basically remove this x, we can just put it here, so x equal to 4. X is less than or equal to 4. So let's draw this on the number line. Let's put a 4 here, and then that would be our number line. So let's do a harder one or a more trickier one. Let's do 28. Also for these, you can see that we don't really have to do number 1, so let's just want to do one of these. So let's do 18. So question 18. So let's just simplify this first. So 3 times 2, it's going to be 6. X minus 3 times 1 is 3. So as we can see, we have an inequality here. So we can just remove. So let's say we want to keep this number. So we're just going to add 3 to the other place. So it's going to be 14 minus x. So we can just basically add an x here and add 1 here as well to just remove them. So it would be 7x. And since we add a x here, it's just going to be 0. So we can 7x is, we can just simplify this, so 2. So that would be our inequality. X is greater than or equal to 2. We don't have to write this because it says not to, so we'll just continue. Let's do number 28. So let's do number 24. So 24, it's simple. This is easy. We can just do it like the one we did. So 3x plus 9 to x minus 1. So we can just basically simplify this further. So we can just minus 2x here, minus 2x here, and we can use minus 9 here and minus 9 here. So it would be x is greater than, so minus minus, we can just use minus 10. So that would be our inequality. Let's do number 28. As we can see, this is 3 inequalities, so this is a bit tougher. So it's not really that tough. We can just we have to basically do the same thing for each of these. So we can see that all of these can be divided by 3. So we can just put x here. 6 divided by 3 is 2, and this would be 5. So that is our inequality. Let's do 27 since this looks a little complicated. X plus 5 to x minus 1 by 5. We can just cross multiply, we can just cross multiply this, so it would be now let's simplify this. And then we simplify it further, so we can just 15 x minus 2, and if we add 2 here, we'd get 17 is greater than x. Now let's do 30. Let's just get rid of all of these. So it asks us to find the integer value of x that satisfies each of them. So it's basically like the first question. So let's do number A first. For these, we have to basically do the same thing for each of them. So let's add 1 for each of them. So this would be 4, this would be 0, so just 2x, and this would be 6. As we can see, these can be all divided by 2 here, so we can just write this as x, we can do this as 2, and this could be 3. So our values would be 2 and 3. This is the inequality we have. Let's move on to the next. Let's just put x here. Let's move on to number B. So number B, we can just do the same thing here. Plus 2. So we minus 2 from each of them, so minus 6, minus 3, 3, this would be 9. So we can just divide 3, so minus 2, x, 3. So our x values would be minus 2, minus 1, 0, 1, 2, 3. So these are the values that satisfy this inequality. Now let's move on to question 31. So for question 31, a rectangle has width of a centimeter and length of 2a minus 5 centimeters. The perimeter of the rectangle is greater than 20 but less than 38. Basically we have to write an inequality and solve it. So we know that for a rectangle, let's just draw it. We can see that the length is 2a minus 5 and just 8 centimeters. So we know that the perimeter is 2 length plus w. So we can just write this. So our perimeter would be 2a minus 5 plus a by 2. So we just simplify this, we can see it's 3a minus 5. And if we simplify this further, 6a minus 10. This is our perimeter. So let's put that in our inequality. So 2 greater 6a minus 10 less than 38. So let's add 10 for all of this. So 6a, this would be 0, so 48. And we can see that 30 and 48 can be divided by 6. So that would be 5 by a, and we know 48 divided by 6 is going to be 8. So this is our inequality. Let's move on to the next question. For the next question, we can see Sajid's age is y years while his brother's age is 2y minus 4. So the total of their age is greater than 11 and less than or equal to 23. So this is the same as the question we did before, so let's just quickly, so we can see it's greater than 11, so cool. And we can see that their age is going to be 2y minus 4 plus y, but it's less than or equal to 23. So let's just simplify this further. So this would be 3y minus 4, 23. So let's continue simplifying it. So this would be, we add 4 here, so 15 by 3. We add 4 here, so 27. So we can see that both of these numbers can be divided by 3. So let's just simplify this further. We know that 27 divided by 3 would be 9. So this is going to be our inequality. And state the greatest number b is how to state the number that can be. Oh, sorry. So the answer would be 9, or y equal to 9. This would be the highest. I made a slight issue, so we know that this, we can just see that the highest number here, it is 9. So if we substitute it in his year, so 2y minus 4, if we substitute 9 here, we get 2 times 9 minus 4. So that would be 18 minus 4, which is 14 years, which is our answer to number B. So before we move further, we want to know how graphs work in inequalities. So let's draw an x-axis and a y-axis, and then let's draw the little points. So 1, 2, 3, 4, minus 4, minus 3, minus 2, minus 1, 3, minus 2, minus 1. So this is kind of bad, but let's deal with this. So there are two types of, or mainly 3 types of inequalities in graphs. X greater than number or equal to, or we could just, or then x number. We also have y. So, and we also have both, so which is going to be something like this, or basically these are the graphs that we can find. So let's say we have x is less than 2. So since it's x, we have to find it in the x value, so this point. So we draw a line on the x1. Well, not a line. Since it's a normal sign, we have to draw a dotted line. So, and since it's less than x, so it's going to be this area. Let me draw it using a different. Sorry. It's kind of terrible. Let me quickly fix it up. So this place over here would be our shaded area. So, but let's say this was an equal sign. So x is equal to or less than 2. Then our line would be a straight line. Let me just do that real quick. Yeah. But and the shaded area would be the same. So basically, let's draw another one. So that would be, let's quickly erase this. Let's say it was x greater than 5. So we just find the 5 line. Let's just draw 5 line real quick. We draw it dotted since it's a normal sign. Extend it a little. And since it's greater than 5, it would be this region here. We have to shade it entirely. I can't right now. It's this area. It would be. But if it were a sign like x is greater or equal to 5, then we know this would be a straight line. And the area would be the same. So this part. it goes on. Now let's basically do the y graphs. So y is less than x. Oh, sorry, 10. Let's just do a short number, so 2. So this would be a dotted line on the y-axis. And since y is less than 2, we can know that this is this area here. We have to shade it entirely. I'm not doing it right now because yeah. But if it were an equal sign, so it's less than or equal to, we know it's going to be a straight line. But let's say if this one right here was 2, that would mean that this would be a straight line, and this place would be, and this would be shaded. Same with here, so if it were a sign like this, it would just be a dotted line, and this place would be shaded. So let's stick with these two inequalities, then we'll do the other one. For these questions, we have to basically identify them instead of drawing them. So we can easily do that. We can see that this is a dotted line, so we know it's going to be just a normal sign like this. And we know it is placed on the x-axis on 2. So we just put an x here and a 2 here. So we know that this is increasing. As we go further, it's increasing, it's not decreasing. So x is frantically increasing, so we know that this would be the sign. This would be the same for number b. Let's write number b here. We know it's on -2, so y and -2. We know it's a dotted line, so it would be a normal sign. And we can see it's decreasing, so -2, -3. So we know what -2, y is getting less than -2, so our sign would be y is less than -2. Let's move on. So the next ones, we can just see that it's a little different. So y equal to 2x, that is the gradient, or yeah, the gradient of this thing, or the equation. So we can see, basically we can do something really easy here. We can basically find a portion of we see that this is y and x, 2 of them are involved. To do these graphs, we can just, or like identify these graphs, we can just place a dot here on the shaded line. We see that this is 1, 1. Since we can see that we can just substitute this. So y we know is 1, so we just put 1 here, and 1 is equal to 2, so 2 times 1. And when we multiply it, we get, so we know that 1 is logically less than 2, so, and we know this is the dotted line, so this would be that this, so 2x, that would be our answer. We can do the same thing here, but let's just choose 6, so this would be 6, 0, 6. So y equal to x plus 4. Let's just put 6 here and 0 plus 4. We get 0 equal to 4. And since this is a straight line, we know it's going to be equal to. So 6 is greater or equal to 4, which means our would be y is greater or equal to x plus 4. That is our answer. Try doing these yourself. I'll put up the answers in a second. Pause if you need to. Now for these questions, we can first write the coordinates, so let's do that real quick. I'm going to be using this one here as I'm not really a good of a drawer. So let's do 2. So y and -3. So let's just put it here, the dot. And we can see that this is a normal graph, so this would be dotted. So let's draw a dotted line here. And we see that this is y is greater than -3. So this would be this section. Let me just use a tool here. So it would be this area here. Just shade it all. And for this goes for all of the questions. So this is x is n minus 1. So let's just quickly draw one in the x-axis. And we can see that this is an equal to sign. So we're going to do a straight line. And we know that here x is greater, so it's increasing. So our shaded area would be this area. Just shade it in and we'll be good. So just shade this area. So we know that these ones here, they're a bit different. So let's just remove this. So for these ones, let's say number 4, y equal to or is less than 3 minus x. So for these, we have to basically make it y equal to 3 minus x, and then we have to substitute. So when is y, let's say, what number is x when it meets the y axis? So let's say which point of the x-axis is in the y-axis. We know that's automatically 0. Same thing for the x-axis. So we know the y-axis in 0. So we have to just substitute y. So 3 minus or 0, my bad. So we get y equal to 3. And here, put y here, 3 minus x here, so 3. So let's just see that 3 here, and then we draw a dotted line since it's so. And then we see that y is less than. We can just prove this. We can just take either one of the coordinates here or here. Let's pick this coordinate since it's easy. We can just y or 0 equal to 0. We can see that 0 is less than 3. So our inequality would be we can see that over here in our original one, it's this 3 minus x. We can see that this sign, if you put it here, it makes this normal, right? It's not this. So we know that this is the shaded area, so we just shaded it. So I'm sorry for my bad sketching skills, but this would be the answer. Let's move on to another one. So let's quickly do number 8 since this looks hard. So we basically 3x plus 5y equal to 15. So let's just substitute them real quick. So if this is 0, then y equal to 3, and if this is 0, x equal to 5. So this. So we quickly write them here. And since this is a normal sign, it's not equal to, we can just draw a dotted line here. And let's basically choose this since it's easy. So 0 plus 0 is greater than 15. So we can see that this does not follow the logical name. So because we know that 0 is not greater than 15. So that means this part is not the shaded area. So it would be this area, the opposite area. And if you want to prove that, let's say we pick this coordinate here. This is 2, 3. So if you were to put 2 plus
5 times 3, 15. And we get 3, 6 plus 15, which we know is actually greater. This proves it. So we know that this is the shaded area.
That's for the first two exercises. We'll move on to the next exercise in the next video.